Why build your own system for user management if you can use federated identity management? Delegate user authentication to external identity providers such as Google, Facebook, Twitter, or GitHub. This will minimize your effort for user administration. With federated identity management, you don't need to implement, secure, and scale a proprietary solution for authenticating users. It's important to monitor the status of your application and services to ensure that they're always available and performing optimally. The monitoring data can be used to automatically alert operations teams as soon as the system begins to fail. Operations teams can then diagnose and address the issue promptly. Implement a health check endpoint for each service. The endpoint handler should check the health of all dependencies and infrastructure components required for the service to function properly. For example, the endpoint handler can check the performance and availability of storage, database, and network connections required by the service. The endpoint should return an HTTP response code of 200 for a successful health check. If the health check fails, the endpoint handler can return 503 or a more specific response code depending on the error. Evaluate which dependencies are critical enough to result in a health check failure. For example, consider a UI service that displays recommendations in one section of the web page. The UI is designed to degrade gracefully, meaning hide the recommendations section if the recommendations engine is down. With this design, if the recommendations engine fails, you can report the failure on the health status web page, but still return a successful health check for the UI service. This approach ensures that your application continues to receive traffic even if some non-critical dependencies are unavailable. A health monitoring agent such as a load balancer or Stackdriver monitoring can periodically send requests to the health check endpoint. Load balancers use health checks to determine if an application instance is healthy and is capable of receiving traffic. If the health check fails beyond the threshold that you've defined, Stackdriver monitoring can send you an alert automatically. Set up logging and monitor your application's performance. Treat your logs as event streams. Logs constitute a continuous stream of events that keep occurring as long as the application is running. Don't manage log files in your application. Instead, write to an event stream such as standard out and let the underlying infrastructure collate all events for later analysis and storage. With this approach, you can set up logs-based metrics and trace requests across different services in your application. With Google Stackdriver, you can debug your application, set up error monitoring, set up logging and logs-based metrics, trace requests across services, and monitor applications running in a multi-cloud environment. When accessing services and resources in a distributed system, applications need to be resilient to temporary and long-lasting errors. Resources can sometimes become unavailable due to transient network errors. In this case, applications should implement retry logic with exponential backoff and fail gracefully if the errors persist. The Google Cloud Client libraries retry failed requests automatically. When errors are more long-lasting, the application should not waste CPU cycles attempting to retry the request over and over again. In this case, applications should implement a circuit breaker and handle the failure gracefully. For errors that are propagated back to the user, consider degrading the application gracefully instead of explicitly displaying the error message. For example, if the recommendations engine is down, consider hiding the product recommendations area on the page instead of displaying error messages every time the page is displayed. Consider data sovereignty and compliance requirements. Some regions and industry segments have strict compliance requirements for data protection and consumer privacy. For example, European Union's Data Protection Directive regulates the processing of personal data. The directive specifies a number of requirements that companies must meet around protecting personal data. Review the data protection requirements for the industry segments and the regions where your users and services will be located. For more information about security and compliance in Google Cloud Platform, see the Downloads and Resources pane. In addition to executing functional and performance tests, execute high availability testing as well. Such testing will enable you to develop robust disaster recovery plans and perform disaster recovery practice exercises regularly. Identify failure scenarios and create disaster recovery plans that identify people, processes, and tools for disaster recovery. Initially, you can perform tabletop tests. These are tests in which teams discuss how they would respond in failure scenarios, but don't perform any real actions. This type of test encourages teams to discuss what they would do in unexpected situations. Then, simulate failures in your test environment. After you understand the behavior of your application under failure scenarios, address any problems and refine your disaster recovery plan. Then test the failure scenarios in your production environment. You can perform canary testing or blue-green deployments on your production environment. Consider scheduling such testing during a maintenance window or during off-peak hours to minimize impact. Consider failure scenarios such as connectivity problems, on-premise data center or other cloud provider failure, GCP zonal or regional failure. Zonal failures are uncommon and regional failures are extremely rare. Also consider scenarios such as deployment rollbacks. In some cases, you might have to roll back a software deployment to an older stable version. Test the rollback procedure. Also check for data corruption caused by network or application issues. It's important to have a process to restore data from backups in case of data corruption caused by network or application issues. In each of these failure scenarios, make sure that the appropriate people were notified about the failure in a timely manner and that traffic was rerouted using redundant routes. Make sure data was not corrupted during the failure or recovery process and that all services were restored in a timely manner. Implement a strong DevOps model with automation to enable continuous integration and delivery, or CI/CD. Automation helps you increase release velocity and reliability. With a robust CI/CD pipeline, you can test and roll out changes incrementally instead of making big releases with multiple changes. This approach enables you to lower the risk of regressions, debug issues quickly, and roll back to the last stable build if necessary. In a continuous integration system, developers commit code into a code repository such as Git. A build system, such as Jenkins, automatically detects commits to the repository, triggers builds, and runs unit tests. The build system produces deployment artifacts for all required runtime environments. In a continuous delivery system, a deployment system such as Spinnaker automatically triggers the deployment of builds to test environments. You can automatically execute integration, security, and performance tests, and then deploy successful builds to your production environment. When rolling out builds to the production environment, consider performing canary testing or blue-green deployments to make sure that any unexpected issues do not affect a large number of users. You can set up performance metrics and alerts to monitor the application's performance in production. It's important to consider security throughout the continuous integration and delivery process. With a SecDevOps approach, you can automate security checks such as confirming whether you're using the most secure versions of third-party software and dependencies, you're scanning code for security vulnerabilities, confirming that resources have permissions based on principles of least privilege, and detecting errors in production and rolling back to the last stable build. If you have a large code base of legacy applications, don't worry about your journey to the cloud. Consider using the strangler pattern when re-architecting and migrating large applications. In the early phases of migration, you might replace smaller components of the legacy application with newer application components or services. You can incrementally replace more features of the original application with new services. A strangler facade can receive requests and direct them to the old application or new services. As your implementation evolves, the legacy application is strangled by new services and is no longer required. This approach minimizes risk by enabling you to learn from each service implementation without affecting business-critical operations. The term strangler comes from strangler vines. The vines seed and start growing on the upper branches of fig trees, gradually envelop the tree, and finally kill the tree that acted as their host. Use the strangler pattern to re-architect applications. Design, develop, and deploy your application with global reach, security, scalability, and high availability in mind. Use a code repository for source control, a package manager to manage dependencies, and a CI/CD pipeline to release your application. In the design battle, microservices win over monolithic applications. Loosely coupled microservices, asynchronous operations, stateless components, and caching. These implementation choices can really help you build a highly scalable and reliable application. And remember, if you have a huge code base of legacy applications, you can take your time to re-architect them and move them to the cloud. Use the strangler pattern.